Welcome to the video for C5.3.3. We're going to look at choosing reaction conditions for equilibrium. So pause the video and have a go at these two questions, which you should be able to do based on last lesson. So hopefully you've remembered from the last lesson that if you have a high pressure, it favours the side with the fewest moles of gas, and if you have a low pressure, it favours the side with the most moles of gas. So if we look at the equation, we've got one carbon monoxide molecule and two hydrogen molecules. So we've got 3 moles of gas in total on the left-hand side, and we've got 1 mole of gas on the right-hand side. So we have got fewer moles of gas on the right-hand side. So to favour that forward reaction, we want an increase in pressure. Where temperature is concerned, so that minus sign means that it's an exothermic reaction. So if we want to favour the exothermic reaction, which gives out heat, we want to lower the temperature. So I'm not going to read the learning objectives. If you want to read them, you can pause the video. So when we choose, last lesson we looked at why we might want to change the pressure, the temperature, in order to increase the percentage yield. But sometimes we don't use the ideal pressure or the ideal temperature, we use a compromise, and this lesson is going to tell you why. So if we look at this reaction, a high pressure is going to give us the maximum equilibrium yield of the methanol, which is our product, because we've got more moles of gas on the left-hand side and fewer on the right-hand side. So increasing pressure is going to give us the most amount of methanol. But if we have high pressures, they need expensive equipment to compress the gas. They need expensive reaction vessels because they need to have tougher walls to withstand the high pressure, and it needs a lot of energy to run. So in practice, we use a compromise pressure. So if the ideal pressure was something like 200 atmospheres, we might use 100. So it gives us enough pressure that we increase the yield a significant amount, but it's not that much that it becomes expensive and needs lots of energy. It's also, if you have high pressure, it's also unsafe. So in terms of temperature, so this reaction is exothermic, so we would want a low temperature to make the most amount of methanol. However, as we know from our previous unit C5.2, when we looked at rates of reactions, if we have a high temperature, it gives us a faster rate of reaction. So if we have a low temperature to give us the most amount of yield, the rate of reaction is going to be too slow. So we have to use a compromise. So if the ideal temperature was something like 50 degrees C, we might use something like 200 so that we increase the rate of reaction. So catalysts, as we learned last lesson, don't affect the position of equilibrium, but they do speed up the rate of reaction. So it's not going to give me a higher yield of methanol, but in the same period of time, I will get more methanol because the rate of reaction is going to be sped up. And we use catalysts because even though they're expensive normally, you can continually reuse them because they're not changed or altered by the process, and therefore that overall lowers the cost. So key points, so pause this video and copy these key points down. There's a separate video on a model 6-mark question, which you can have a look at if you look in the playlist for model questions. And then you can also pause the video and have a go at this. The mark scheme's on the next slide. Okay, so check your answers and check you've got them all correct. Okay, thank you for listening. See you next time.